Okay, so let's move forward because we have only like 40 minutes for the camera stuff. Let me go back to our notes. And here we have, so we have done all of this. Oh no, we haven't, oh sorry, there's another part here, which is mix the base color with the texture color. And if you look at the assignment, you'll see that there is a part here, no, here, that say mix the base color with texture color. And this is pretty much related to having one shape using the texture and having another shape using solid colors. So look at the scene here. The sky, as I mentioned, is this blue box, and it's not using the texture. But these cubes are using the texture. So but you have only one shader. So how do we do that? Right? How do we have different cubes using, or certain cubes using color or solid color and other cubes using texture? And this is this part of the assignment. I'm going to skip it for now because, I mean, first of all, the instructions are here, but because I'm afraid we need some extra time, I want to work with camera with some good time, so I don't want to rush on that part because this is a very important concept. Basically, a camera is implemented throughout two matrices. And because when you move a camera, what you're doing is you can think of it as moving all the objects in the world, right? Because a camera is just a point of view, right? So if instead of, you can think of the point of view as like, imagine if when you rotate the camera, you're actually rotating all the other objects on the opposite direction. So you have this illusion of a, or not illusion, but you actually have a camera that is just this point of view that all the other objects in the world move relatively to this point of view. And to implement this trick, let's say, we have to use two matrices. One that is called the view matrix, and the one that is called the projection matrix. So the view matrix is this matrix that stores these transformations of, let's say, rotation and translation of the world relatively to this point of view. And the projection matrix is going to give this idea of perspective. So something that also a camera does is implementing this idea of perspective that we see, for example, if you're far from the object, you see it smaller, and if you're close to the object, you see it bigger, right? So let me start this by adding a view and projection matrix to the shader. Let me see. Here, what we want is we want two matrices here. One is called the view matrix. Okay, it should be okay. View matrix, and this is a projection matrix. Okay. Let's start with the view matrix, and let's create a matrix and make it a view matrix and see what happens with our scene. Okay, and to make it effective, to make it work, we're gonna build a matrix in JavaScript, send it to the shader, and then apply it to the scene. And to apply it to the scene, it's simply multiplying it from the left here. We're multiplying after our model matrix. We're gonna apply these transformations to all the vertices. So essentially, remember what I mentioned is, a camera is pretty much, you change all the objects of the world. So essentially, you don't have a virtual, like a camera that is an object there. It is just an idea. So it's just a point of view. It's just that is represented by these two matrices. But if remember that essentially when you multiply by the vertex, what you're changing is actually the shapes and not the camera itself. Let's implement this and see this in action so we can discuss this a bit better. But yeah, a view matrix. So we have to create a view matrix in our scene. And we can create it here, I guess. So we can create a view matrix. And first of all, a view matrix is a matrix. So I'm going to call this view matrix here. And oh, sorry, not u view matrix, but I'm going to call a view matrix. And we have a new matrix 4. This matrix 4 comes from our library. Okay. This is a matrix 4. And if you look at this class, it has a function called, let's see, where is it? Set multiply by 4 transpose set inverse of orthographic, no, ortho, set perspective, where is it? Set scale, no, set translate. I think it's set view matrix, sorry. Oh, let's see, let me just check this. Set, okay, forgot. Is set look at. Set look at. So this is pretty much, as you see here, is setting this view matrix. Okay. And this has 1, 2, 3, 4, 5, 6, 7, 8, 9 parameters. The first 3 parameters are the position of the camera. This other 3 parameters, next 3 parameters are the position of the reference point, or you can think of it as where you're looking at. So you imagine the camera to be, so the camera has this eye point, which is where it's at, and then the center of the camera where it's looking at. And then the up vector is the up axis of the camera. So if you think of a camera as your right hand, right, the up vector is going to be your thumb. And you can think of it as the center of your hand as the eye position, and the tip of your index. So the tip of your index finger should be your center point. Let me turn on my camera and see if I can explain this a bit visually. Where's the camera? Okay, so I don't know if you can see me. There's too many things in my screen at this point. Can you see me? Because I can't see my video. Where is my video? Okay, so but basically what I want to say is, so can you see my hand? Okay, so what I was saying is that if my hand is the camera, the center point, so the eye point is this point, is actually the joint of where my index finger starts. So you can think of this point here is my eye point. The center point is the tip of my index finger. So this is my center, and the up vector is my thumb. So the camera is kind of like acting this way in the world. So if you rotate the camera, you're gonna rotate it this way. If you move it forward, you're gonna move it this way. So the camera is always gonna be looking at the end of the index finger. And it's gonna be, and this vector is important for orientation. And every time you rotate, you're gonna do this, and if you move, you're gonna move it this way. So you can think of the camera as using this kind of right hand rule, or opening it this way. And it's a good way of imagining or understanding what a camera is. Oh, I stopped sharing. I want to. Okay, I want to stop my video. Okay. Is it still recording? Let me double check. Yes, it's still recording. Okay. Yeah, as you read the book, also this is going to be much more clear. Um, but and also we have, I think we have a good reference here, and I do recommend reading that. If you open this resource, I think this one. Let me see. Yeah, this tutorial has a really good explanation of cameras. I think you should keep going here. You see like this, the image of explaining these points. And here you also have visualizations of the camera in 3D, and you can change the parameters. So I think this is a very good way to understand how to implement a camera. First of all, this is fully implemented camera in WebGL. So you can also use this as a reference for your code. But it's a very nice, I think it's a very good illustrated tutorial for this concept. Okay, so let's call this function in our, here, we're gonna say view matrix dot set look at. But now what we need before, we need to have those points like I, up, and center, and I'm gonna make them actually as vectors, and we have a vector3 class as part of our library. Let me show you this. Right, we have this vector3, which actually you used in the lab 0. You implemented all these functions in lab 0. So we're gonna actually now use these functions. But now, so I wanna make a vector3 here, which is our I. So let I equals new vector3. And then I'm gonna say let center also be a new vector3. And up equals to new vector3. So even though we are using vectors, I think this is a point that we are using. A point also has position x, y, and z, but it's important to understand that conceptually this is a point and not a vector. This is a point in space, and this is also a point in space. And let's initialize this, guys, with some values. So I want to start this I position to be 0, 0, minus 10. So basically, I'm just putting the camera position, I'm putting it to be minus 10 on the z-axis from the origin of the world. I want the center to be 0, 0, 0. So essentially now the camera is minus 10 on the z, looking at the center of the scene. Remember that center is our where we are looking at. So you're going to be looking at the center. Okay. And my up vector, it starts 0, 1, 0. Okay. Which is the y-axis, because the camera is not rotated yet. But once if you rotated it, especially if you rotated it up and down, if you tilt it up and down, then the up vector is gonna change. And remember your thumb, you can think of your thumb to do that. If you rotate your camera up, you'll see that your thumb is not aligned with the y-axis anymore. And that's it. And here, what I have to do is, unfortunately, I'm going to have to pass these values one by one. So I'm going to say I dot elements 0, I dot elements 1. I'm going to have to do this one by one. This is going to be 2. This is 1. Oops. This is 1. And now I have the center points. I'm going to copy this just to make it faster. But the second one is the center point. Center. And the last one is up. Okay. Let's organize these things. So that's it for viewing. With this matrix, we now can move the camera. Uh, we now have it. We have this matrix on the CPU, but now we have to send it to the GPU. And basically, we have to use that same is a uniform, right? We have to set this matrix in the shader, and that code is the same line we're gonna have to retrieve the matrix, right? I'm gonna have to retrieve the variable in the shader. So I'm gonna copy that line and say u underscore view matrix, and I'm gonna read the view matrix from the shader. And now I have to update the matrix. And to update the matrix, we can copy it from here, from our rendering loop. We have this function is used for updating the matrix. You're gonna use the same one for the view matrix. So now, view matrix false, and this is view matrix of elements. So here we are creating a view matrix. Oh, it's all part of that. Okay, so this is all part of this. Okay, I think that's it. Let's see what happens if you reload the scene. Syntax error, okay, 166. I think I forgot maybe, oh yeah, I forgot some commas. We don't see anything because, wait, we have a view matrix. Let me check the names here. Model matrix. View matrix, and this is view matrix. And this is view matrix. This is also view matrix, view matrix. And let's see. False. View matrix dot elements. Okay. Oh, wait. We are doing this. Wait, we are doing this. You know what? Let's call this at the very end, because I'm afraid. Let's make sure that everything is called before this texture loading function is executed. Oh, interesting. What am I missing? Set look at. Let me print this matrix and see what happens. Okay, it's here. Let me change some values here and see what happens. 10. This one. Okay. That's what I was expecting. Why -10 didn't work? Let's see, -2. Let's see, at some point probably is. Oh, I see, okay. We don't have a projection matrix yet, so I think the effect is gonna be, let me try one a second. Okay, now you're seeing the back. And now you're seeing the back of that. And this should be the front. Okay, this is the front, yes. I believe, yeah, I think this is the front. And it's hard to debug the camera only with a view matrix because it's not intuitive. So, but we do have something, right? It's actually there. It's taking some effect when I change the matrix. These things change. And one thing that I can do is maybe if I move my center point 1 unit to the right and also move my eye point one unit to the right, I'm moving my camera to the right by 1 unit. So I think we should see the object on the left. Let's see. Okay, I think it's the opposite. Okay, so if I do -1, -1, I should see them on the other side. Okay, and this is probably, we are looking, I think we are looking, we are at the back. I think we are at the back of the objects. But if you do this, if you put 1 here now, let's put, yes, no, wait, I'm confused. Yeah, without the projection, it's very hard to debug this. Okay, let's wait to debug this. What I want to do is just, I'm just showing that the view matrix is working, but before debugging it, let's put the projection matrix in there. Okay,